this video, we're going to cover optionals. I will warn you, optionals are one of those concepts that take a little time to get used to, both from a programming standpoint and conceptually what they are, but I will do the best I can to explain it, and we will have more than one optional video to review the concept, and we'll have quite a few labs and exercises associated with it as well. So let's get started. Optionals. So what I'm going to do is cover 4 different concepts associated with optionals. One, we're going to talk about what they are. We're going to look at how we declare them. We're going to look at how we use them. And we're going to look at why they even exist and what they're good for. So let's start out with this sort of graphic. And it says, you know, it's your lucky day. And essentially, you've been given a present, and you're just thrilled that you got this present. And you go to open the present, and you find out there's nothing inside. And I'm guessing that that's going to make you feel kind of angry, like you got a present and it's just an empty box with nothing in it. So when there's nothing inside, we refer to this as nil. Nil is like a nothing. It's not 0 because 0 is a valid integer number. It's just empty. It doesn't exist. And so therefore, in this box, if there's nothing in the box, you did not receive a present, then this is referred to as nil in the language. And one of the rules that we want to reinforce is that you never want to open up a box and find nothing in it, right? That's going to make you feel bad. And in Swift, if you open up a box, which this is relating to basically a variable, and you reference that variable and you open it up basically to get the value of that variable and it's nil, your program will crash. So Swift really does not like the fact that it opened up something and got nil. To avoid this problem, Swift has adopted a standard for marking all of our presents, if you will. So marking all of our variables with a question mark for those things that could potentially not have anything in them. And this is what we refer to as an optional. So here, for example, this present actually could have nothing in it. And therefore, there is a question mark that's put on the side of that present. And that tells you that, hey, there may or may not be anything in this present and in this box. And the rule is you don't want to open it if there is nothing inside. You don't want to waste your time doing that. And so how do you do that? Well, it turns out that there is a way to sort of use X-ray vision and look inside the box. In this case, we're using this magnifying glass to sort of see if there's anything inside. If we look inside and we don't see anything, then we do not open the box. We know that it's nil. If we do see something, then we know we're fine and we can open the box. So what it's showing here is if the present does have something, we can go ahead and open the box. And the term that we use for opening the box is unwrapping. We're basically unwrapping the present, we're opening it up, and we're taking whatever inside. We're referencing that. And that's fine as long as it's there. So that's what that question mark does. It says, and it warns you, it says, hey, this may or may not have something inside, so you're going to want to use your X-ray vision and check to be sure that there is something inside before you unwrap it. Now, if you don't see a question mark here, then you know that there is always something inside. You don't need to check for it. In fact, it's not even legal at that point. So if you don't see a question mark on a variable, then it means that you are good to go and you do not need to unwrap it. This is for variable declarations. So no question mark, hooray, we know there's going to be something inside the box. So this code says gravity, the variable here, will always have a value. And the reason that's the case is because we don't see a question mark anywhere. There's nothing that says that gravity is optional. So this value that we've given it here is always going to be there. Now, because it's a var, we could change that value later to a different value, but it will always have a value. And in fact, this next statement is illegal at this point. In other words, we can't set gravity to empty. We can't take that number that's in the box, take it out, throw it away, and leave an empty box. We can't do that because gravity is not an optional, and therefore it always has to have a value. This is sort of saying, hey, gravity, you are going to get nil. You're assigned to nil, which means you have an empty container, and the compiler won't let you do that. Basically, we'll get an error at compile time that this is not legal. On the other hand, if I declare gravity and the double, which is the type, has a question mark at the end, now that's different. That means that we have this present called gravity, and inside it, it may or may not have a 9.8. But the main point is that the question mark is telling us that it may or may not have a value. In this case, we've assigned it a value, but what's interesting is this next statement is now legal. So we could say gravity equals nil. We can take that 9.8 out of the box, throw it away, and leave it as an empty box, and that's totally legal because we declared it with the question mark. So the next question is, can we do this? So we're in a scenario where we have this variable gravity. Double is said it's optional because it has the question mark. And it does have a value here, but what we want to do is say, let's say we want to calculate a velocity. So what's the velocity after 5 seconds? Well, that would be gravity times 5. So in this scenario, the question is this legal? So it turns out that this is not legal. And the reason is that because gravity is an optional, to get to the value, you need to unwrap the package, if you will. You need to unwrap it and go inside of the box and get the value, and that's because it's an optional. So, for example, here, we're not doing anything special. We're just reading the value of the variable. So we aren't really doing an unwrap, if you will. And the way we do an unwrap is with an exclamation point, sometimes referred to as bang, as an example. So here, gravity now is unwrapped, and whenever you use the exclamation point or bang, either name is correct, you're doing what's referred to as a forced unwrap. We are forcibly unwrapping this box, and we're hoping to gosh that we have a value inside. And it turns out as we read this code here, we're confident that we will have a value inside because the statement right before it, we can see that it put a value in there. So when this runs, this will run just fine and we will not have a problem. But you want to be careful with force unwrapping things because if you force unwrap something and there's nothing in it, you are going to get a crash. So what happens here? If we do this, here we're saying gravity is an optional, but we didn't give it a value. So that means it has nil inside it. Then the velocity calculation is force unwrapping gravity. And guess what happens? When we force unwrap something and there's nil inside, bad things happen. That's when we get this explosion, if you will. So this is now the error message you're going to get. It's going to say something about executing bad instruction. And essentially that's because we force unwrapped a package that had nothing in it. And again, we want to avoid that. So we didn't really use any sort of X-ray vision to check this first. And that's really what we would want to do. So here's the way to do this initially. And we have even some better ways, which I'm going to show you in a second. But the first way to do it is to say, we look at these statements, 1, 2, 3, and 4. The first one is the gravity statement, where we've declared gravity, we've said it's a double, and we've said it's optional, right? Because we have the question mark. Then what we can do is before we do this statement and before we do this force unwrapping, we can say, does gravity have a value? So we're saying if gravity is not equal to nil, meaning that it does have a value, then go ahead and force unwrap it. However, if it is nil, this if statement won't run, right? And so, I'm sorry, the if statement will run, but the statement 3 won't execute. So in this scenario, it's safe. So what would run in this scenario? Statement 1, 2, and 4 would run, but 3 would not. Now, if we gave gravity a value on statement 1, what would run? Well, 1, 2, 3, and 4, because we're saying gravity is not nil, so we can go ahead and do statement 3. And we can force unwrap it safely because we've already checked ahead of time. Now, what I want to do is show you another way to do this that's a little better than this particular method, and it avoids this force unwrapping here. So now in this scenario, we have a little bit different syntax. So here what we're doing is we've got the same thing for statement 1, but now we have this new syntax which says if let g equals gravity, and then we actually use the g here in this statement. So let's just talk through what this is. We would refer to this as an if let. So you'll hear that term a lot. An if let is what you're going to use to basically check an optional to see if it has a value or not. The nice thing about the if let is that it not only checks to see if it has a value, but then it unwraps it for you and puts it into a new variable that you can then just reference without unwrapping it yourself. So for example, here we see if let g equals gravity. So what this is saying is gravity is examined to see if it has nil. If it has nil in it, this if statement, that statement inside the if will not run. But if gravity does have a value, it will put that value into g, puts it into that new variable, and now we can reference g, and we don't need to force unwrap it because g is not optional. G is just the constant here. It's a let of g, and this did the unwrapping for us as a part of this statement. So here we can just refer to g without doing the exclamation point or bang at the end of it. So when you find yourself in your code where you're doing a lot of these, you've got a variable and it's an optional, so you need to do the exclamation point to unwrap it. And let's say you know that you could unwrap it because you know for sure you're going to have a value in there. You can do the if let. Not only is that safer because it now is letting the runtime system, it's letting it as it executes, it's checking live to see if it has a value or not. And if it does have a value, it's giving you the variable that you named here to be used throughout your code in this if statement without doing the exclamation point. So without doing the force unwrap. So let's discuss briefly about why optionals are important. What do we use them for? So in this example, I have created a struct called book, and it has 3 different properties associated with it. It has title, author, and ISBN. And we could imagine that if I was in the middle of writing the book and I haven't submitted it for publication yet, that I might want to store the fact that I have this book that I'm working on, but since it isn't published yet, it doesn't have an ISBN number. So this would be a classic scenario that says every book is going to have a title and an author by definition, so we don't make those optional. However, the ISBN may or may not be there, and the way we express that in Swift is to put that question mark at the end of the type. So we'd say ISBN is a string, but it's optional. Sometimes it may be there, sometimes it may not be there. Then when we initialize it, here's our initialization where we say var myBook equals book. Here's the initializer that we've looked at before for structs. And we've got the named parameters here and here. But ISBN, we initialize it with nil. Nil is how we refer to nothing in Swift. And so at that point, we have now given it no value, and that's perfectly legal. What's not legal is I can't put a nil here for title, and I can't put a nil here for author, because these are not declared as optionals. They don't have that question mark around them. And so therefore, they have to have a value. They cannot be nil. Other way that optionals are used is when you are calling a function or you're calling to have something done, and it turns out that it may or may not succeed in doing that. And dictionaries are a perfect example that we'll use a lot, and it's perfectly valid for you to try to get a value out of the dictionary that may or may not be there. So if we look at this particular declaration, we have the my dictionary, which here's the key. Again, that's always a string typically. And then here's the double, which is saying that the value for every key value pair is always going to be a double. And then we initialize it here. So here I've initialized it with gravity, with pi and c, which is short for the speed of light. And I've put the values in here. And this is a perfectly valid dictionary. So what do we get back if you say my dictionary pi? Well, this string goes into this dictionary, it finds pi, and it says 3.1415, right? That's what we would get back with that. But now let me ask you this. What if I said my dictionary golden ratio? What would we get back if we did that? So the interesting thing about this is that golden ratio is not a key in the dictionary. It's not there yet. It either hasn't been assigned yet or it never will be. And therefore, the dictionary needs to say, don't have anything. Returning a 0 is not right because it's not in there as a value 0. So what do we return? Well, we return nil. Nil is empty. It's saying, well, you asked for something in the dictionary. It's not there. So I'm returning nil. So the key point here is that when you're referencing something in a dictionary, what you are getting back is an optional. And therefore, you need to deal with it appropriately because the result of a call to the dictionary with a key is an optional value. So let's look at that in this way. So if we have my dictionary, which we just had, and then what I'm going to do is here's the keys to print, which is just an array of these 4 strings. And we know that gravity, pi, and c should succeed, but we know that golden ratio will not. So if the challenge was, how would you write code after this? So you're going to keep this, but what would you write here to print all of the successful references from the key value pairs from the dictionary? And again, I would break into teams and see what we could do. So essentially what we want is we want to see in the printout 9.8, 3.1415, 186.282.396, but I don't want it to crash, right? Because if you try to do this with passing the key into a dictionary and you don't check it, then you are going to crash if you try to print that. So see where people get. So this is one potential solution. So in this solution, we're saying, well, for key in keys to print, so that's like a cool shortcut in a for loop where we can say, every element in here as we iterate through it is going to become the value of the variable key. So this is going to be start out at gravity, then go to pi, then go to golden ratio, and then go to c. And then we can use our if let. So we could say if let value equals my dictionary keys. Here's where we're referencing the dictionary, we're passing the key, and note that if it exists, this print will print. But if it doesn't exist, it will skip that statement. We will have no error, no crash, no printing of nil. We will just print these 3 valid values. Now, what part of this is optional? So now looking at this code, I would ask, what part of this code right here is the optional piece? And hopefully they recognize that it's this thing right here. My dictionary and giving it a key means that this may or may not succeed depending on what the keys were and what the dictionary was. So that is the optional piece. And this is the part that gets assigned and is no longer optional. Once that's done, you know it's good, it has a value. So you can print that value here without actually unwrapping it. So we've covered the basics of optionals. We've covered what an optional is. We've covered how to declare them. Remember, that's using the question mark. We've learned how to use them, which is basically unwrapping them with an exclamation point. And we also have learned how to check them by using the if-let statement. And then finally, why do they exist? Because there's times when it's perfectly logical for something to be nil, such as the ISBN number or the fact that we're looking something up from a dictionary and it is not going to return a valid value, and that's when we use nil.